Today's lesson is essentially the copy of the lesson that we did from radicals. We solved radical equations algebraically and using technology using graphs or Desmos in our case. You could use a graphing calculator as well. I want you to remember that when we are solving rational equations, we are looking for x values that make the equation 0. That means we are looking for x-intercepts or zeros or roots. All of these words mean the same thing, or solutions is another word. If we are using the graphic method where we are plotting two equations, then we're also, another way to look for solutions is looking for intersections. All right. So in our first example, here's a summary of what we're going to do. To solve algebraically means using math skills. We are going to do the following steps. Number 1, move everything to the same side so that everything equals 0, and list any restrictions, meaning what's in the denominator that would make a denominator 0. Step 2 is we are going to factor out the denominator by multiplying by lowest common denominator, or lowest common multiple, right? We're going to find a common denominator, multiply everything so that we can get rid of it. Then we will multiply each term. We will solve for x. We are going to check the restrictions that we stated in step 1. And if it passes the restrictions check, then we put it into the original equation and make sure that the left-hand side equals the right-hand side. So those are our goals. It sounds like a lot of steps, but these are very logical steps that we are doing. It's not like it's brand new to us. So let's take a look at the example here. Here they have given us an equation, 16 over x plus 6 equals 4 minus x. I look for a denominator. Here it is. What is my restriction? X cannot be -6. So we have to keep that in mind when we're looking for solutions. If we find a solution that says -6, we delete it, right? Okay, I move everything over to the other side. So I'm going to -4, and then I'm going to add x. And you end up with this line here. In order to get rid of the denominator, I only have one denominator. So I'm going to take my entire function and multiply by the denominator. You'll notice that on the right side, I do it as well, but because there's a 0 there, it just stays 0. So I take this factor and I multiply each term inside of my equation. I end up with 6 plus x times x. Then I have this and this denominator cancel out. I'm left with just a 16 here. And then x plus 6 times the 4. Also, please note of the plus and minus signs. One of the most common mistakes is people drop their negatives, or they'll distribute one negative to the first term, but they'll forget about all the other terms. Okay, then distribute. If I expand this, I get x squared plus 6x. That's that piece there, plus 16. And then x times 4 is 4x, but there's a negative here. So I get -4x, -24. And now we collect like terms. There's only one x squared. I have a positive 6x, a -4x. This gives me positive 2x. I have a positive 16 and a -24. That leaves me with a -8. And now I have a much simpler quadratic that I can very easily factor into x plus 4, x minus 2. So my two possible solutions here, x is -4 or x is positive 2. So I've done steps 1 to 4. Step 5 is check against the restriction. My restriction was that I can't have a negative 6. These are not negative 6, so I passed the first check. Let's check the next one. Let's put it back into the original equation. Oh, I did this with a graphing calculator. Can you guys grab a graphing calculator? Can you tell me what is 16? Some of you might be able to do this in your head. That's fine. What is it? Negative 4 plus 6. So the bottom here is what? Negative 2. That gives me an 8. And this gives me an 8. Okay, so it passes that check. Bottom here is 8. 16 over 8 is 2. 2 passes that check. All right, we've done all of our steps. It passes the restriction and it passes the original equation. I have no extraneous roots and no violations. So both of these are valid. I could take the same equation and now solve it graphically using Desmos or a graphing calculator. And the way that we do this is we have two equations, the left side and the right side. So I'm going to grab Desmos here. On the first line, I put the left side of the equation. So 16 divided by bracket x plus 6, close the bracket. My next equation is 4 minus x. Here is the picture. With Desmos, I can just hover over the points and it'll tell you that solution is 2, 2. That solution is negative 4, 8, which matches our picture here. These intersection points are the solutions. Where do the graphs cross over? And we're only worried about the x value. So this solution tells me that 1 is negative 4 and 1 is positive 2, which is what we got up here. So that checks out. The other method, again using Desmos, is to use a single function, which is to put everything on the same side and just type it in as one big equation. So I'm going to add x and minus 4 from the left side. So I'm going to delete this one, go back up here and go plus x minus 4. So I take all the stuff on the right and I put it all together. And now, because I only have one graph, I'm looking for x-intercepts, not an intersection, right? Where does it cross the x-axis? And again, hover over here, 2 and negative 4, exactly what we expected. Oops, x equals 2, x equals negative 4. So we have two methods for using Desmos, and we're going to use Desmos to find our, or double check our math. So let's do an example here. 3x on one side, 1 plus x minus 13 on the other side. Looking at the denominators, what is my restriction? X is 0 is my restriction, so that's got it there. So let's do some math together. We're going to move everything to the same side. So this is negative 3 over x now. When I have a common denominator problem, what did we learn in elementary school? If I have 1 over 5 plus, I don't know, 5 over 6, how do I put this over a common denominator? Greatest or lowest common multiple? How do I get the lowest common multiple? I know it's 30, but how did it get 30? Times them, right? If your denominators are not the same, multiply them to find the common one. So here, my common denominator, or my lowest common multiple, is going to be 6x. Again, pay attention to the plus and minus signs here. When I expand this, 6x times 1 is 6x. 6x times this bracket here, the 6's cancel, but the x remains, so I have to distribute it. X squared minus 13x. In our last term, the x's cancel, but the the 6 remains, so 6 times 3 is 18. Now I focus on collecting like terms. I want to write this from highest degree to low. I see a positive x squared, it's the only one. Positive 6x, I have a plus sign here, so this remains a negative 13x. And lastly, I have a minus 18 here. Oop, I should not have done that in blue. I meant to do that in a different color. Right, so I'm gathering my like terms. I'm going to write them in order from high degree to low. Putting these guys together, here we have. Now we have a leading coefficient of 1, quadratic. We can factor this pretty much in our heads. Two numbers that make negative 18 but add to negative 7. What would they be? Negative 9, positive 2. Okay, so these are my two factors. So the roots are positive 9, negative 2. First thing we do is, does it violate my restriction? No, it does not. Neither of those are 0. So no, we do not have a violation here. Now we check by substitution. I'm going to split my screen here. So 3 over 9 should equal 1 plus 9 minus 13 over 6. And you can, of course, use your calculators here. I don't have one on my screen right now, so I'm just going to do this. What's 9 minus 13? 4. Negative. Which is actually just 2/3. Okay, what's 1 minus 2/3? 1/3. Okay, the 9, good to go. I'm going to do the same thing, but with the negative 2. So 3 over negative 2 should equal 1 plus negative 2 minus 13 all over 6. 1 plus negative 15 over 6, which is the same as, if I minus or divide both by 3, I will get 5 over 2. What would I get here? Negative 3 over 2, which matches the right side. So both of our roots work. We can keep both of them. All right, part B says, use technology to double check your work. So let's go back to Desmos. I'm going to write the left side on one line, 3 over x. The right side on the other, 1 plus bracket x minus 13 divided by 6. Okay, I'm looking for, because I have two lines, I'm looking at where the lines cross over. There is negative 2, and there is positive 9. So we've done this correctly. I'm not going to draw it in here because you can see it on Desmos. Any questions about this example? Okay, let's do the next one. I'm going to give you guys a head start on this one. Same idea. in this one, it's asking you to check using Desmos or your graphing calculator first. Find the 2 roots or 3 roots or 1 root or however many there are. Use whatever method you want. Write it down and then check your work. Okay, so I'm going to pause the video here. I want you guys to do this together.